Welcome to Monochemistry. Today we're going to learn how to do some basic conversions using the metric system, and of course you can apply the same kind of strategy to any conversions you might have to do in chemistry. So really, what is a conversion? Why do we use them? What's the point of all of this crazy math? Well, essentially we're often given numbers, or we're given numbers that we can't really make a lot of sense out of. They're not very useful. For instance, I may have a billion bytes. That's a computer jargon, right? Well, what the heck is a billion bytes? I mean, we're talking in our time, we're talking about gigabytes and megabytes. What does a billion bytes have anything to do with? Well, if you can convert things, then you can make sense out of numbers. You can make them useful. So the system of conversion that generally we use, or the system of measurement that we use, is called the metric system, and it's a great system for a couple of reasons. First of all, it's a base 10 system. So if you know how many of something you have, then you can convert it using measurements of 10. For instance, if I had 1 meter, then I would have 10 decimeters, because it's a 10-time magnification, right? 10-time base 10 unit. And of course I would have 100 centimeters. Now if I had 1 meter, I would only have 0.1 decameters, or 0.001 kilometers. Okay, so the system is very useful. It's a universal system. It doesn't matter where you go, the system is the same, the numbers don't change. And it's a base 10 unit, which makes it very easy to determine mathematically. Okay? So metric system, good. Other systems, not as good. Just to give you an idea, and you don't have to memorize this stuff. The more you use it, obviously, the more likely you are to remember it. But the key here is that everything in the metric system has its place. Okay? So right now we have, this is our base unit right here. Okay? And that would be like the meter or the liter or the gram. Okay, you get the idea. These things then, depending on if you want to convert them, can be converted into numbers that are things that are bigger than the base unit. Okay, like a kilometer is bigger than a meter. Or they can be converted into things that are smaller than the base unit, like a millimeter is smaller than a meter. But here's the cool thing about this system. It doesn't matter what base unit you're talking about. The amount that you convert is always the same. In other words, the centa, meter, liter, gram, whatever, is always going to be 100 or 100th of a meter. There's 100 centimeters in a meter. There's 100 centigrams in a gram. You get the idea. It doesn't matter what unit you're using. Okay? Giga is very big. Nano is very small. Okay? So get familiar with these. Obviously you will be given this. You don't have to memorize it. But make sure you understand how it works. Now, how do we do conversions? Conversions are generally done in chemistry using a system called the factor label method. Okay, so we're gonna show how to do that right here. I'm gonna show you some strategies and how it works. Okay, it's a really useful thing to be able to do. So the factor label method. Let's say somebody walked, Jane. I don't know who Jane is, but Jane walked 10,000 centimeters. Is that really a useful measurement for us? 10,000 centimeters? How far is that? I don't know. I mean, I'd rather know it in meters or kilometers. 10,000 centimeters is useless. I don't know what it is. So I'm going to use the factor label method to convert it to, let's say, meters, just for starters. Okay? So here's what you need to do. You always start off with the factor label method. You always start off with a conversion factor, or a ratio, or if you prefer, a relationship between the units that you have and the units that you're trying to find. Okay? Watch. See if this makes sense. 100 centimeters equals 1 meter. Right? Meter stick has 100 centimeters on it. Right? Okay. So that is a relationship that is always true. If I know how many centimeters are in 1 meter, then I can figure out how many meters are in 10,000 centimeters. That's the idea here. That's the relationship that we're going to use. So I'm going to go ahead and I'm going to write the number that I was given, which was 10,000 centimeters. I'm going to put a bracket. And I'm going to put an equal sign, and I'm going to put meters right there. Okay, so really quickly, take a look at this. This is a ratio. This is a bracket. Okay, up here means you multiply. Sorry, up here means you multiply. If a number goes down here, it means you divide by. Okay? Sometimes you're going to have a number here and a number here. You're going to multiply and divide. Regardless, the key to this is to placing these things, this number and this number, in the right spots. You always want your units that you started with to cancel each other out. You want to be left with the units that you're trying to figure out. So watch this. If I put 100 centimeters down here and 1 meter up here, watch what happens. You guys should be aware that centimeters divided by centimeters equals 1, right? Like that. So what I'm going to do in this case is I'm going to take this number, 10,000, I'm going to multiply it by 1, which is just 10,000, and then I'm going to divide it by 100. 10,000 divided by 100 is 100 meters. And that, in a nutshell, is how you use the metric system to do basic conversions.